Welcome to our third video on adding and subtracting polynomials. Now in this video I'm going to work a little bit faster through the problems. Look back to the other two videos before this for a detailed explanation. But here, you might want to just pause the video, try to solve this problem, and then move forward because I'm going to work my way right through them. So P and R, they give us those two and we're adding them up. Right? They want to know what represents P plus R. So I'm going to add like terms. A squared all by itself has nothing to correspond to. So it's whatever the sum of P plus R is, it's going to have an A squared in it. Next we add A and negative A, that's 0, they're opposites. And then negative 1 and negative 1, which is negative 2. Right? Negative 1 plus negative 1 is negative 2. So I would choose B, A squared minus 2. Here, what is the sum of these two polynomials? Same idea, I'm going to add these like terms. Add the coefficients of 1x squared plus 5x squared, that's 6x squareds. And then negative 3x plus negative 3x, that's negative 6x. And then 2 and negative 8, well that's negative 6. And that's it. And to show the work, you would show each step how you did this. 5x squared plus x, that's 6x squared. Negative 3x plus negative 3x, you can say that's the same thing as negative 3 plus negative 3 times x, or negative 6x, and then 2 plus negative 8 is negative 6. You can break it in parts. Simplify the expression below. And again, it looks overwhelming, but just notice that what's nice about this problem, and they did kind of switch things up on us, 3x squared y doesn't have anything to correspond to across the problem. This over here, for example, the y is squared, but the x is not. So our answer has to either be h or j, because that 3x squared y is still there. So now we combine the next group of like terms, and here we have minus 5xy minus something here. I'm going to choose this one, and notice they're out of order, which is kind of mean, but that's okay. We can deal with that. So negative 5xy minus 4xy. What do we do here? Well, think of the coefficients. Forget the xy for a moment. Negative 5 minus 4. Well, if you're standing here at negative 5 and you take 4 away, 1, 2, 3, 4, it's negative 6, negative 7, negative 8. We're at negative 9. So that should be negative 9xy. And notice h can't be the answer because that's not there. There's our negative, or we're subtracting 9xy. That's got to be the answer. And we can see that 12xy squared minus 5xy squared, those are like terms, right? The xy squared is the same in both. So we can just think of 12 minus 5, which is 7. And that's 7xy squared. So I would choose answer J. Simplify this expression. Well, a squared b, right, whatever that is, it's the same in both terms, so we can just add the coefficients. And we get 9a squared b. Again, the reason is 3a squared b really means that you have 1, 2, 3 of this, a squared b. So if I was to add to 6 more a squared b's, altogether I would have 9 a squared b's, which is what I have there in choice F. Simplify this expression. So 3x squared minus what? Well, x squared. That's 2x squared. Negative 6x minus 4x. What's that? Well, negative 6x minus 4x. We subtract we subtract 4 from negative 6, and we get negative 10x. So we have 2x squared minus 10x. And then we have negative 4 minus negative 2. Negative 4 minus negative 2, which equals negative 2, right? Because it's like adding 2. So I get 2x squared minus 10x minus 2, and I would choose F. In this problem, this relates to a lot of work that you do with transversal lines, but one way to think about it, I think that simplifies it a little bit, is that we have a line right here, right? Trying to draw that. And that means that these two angles have to add up to what? Well, every straight line has 180 degrees. So if I added up the angle 3, oops, that's not good, 3x plus 20, that's an angle, you can see the little degree measure there. So it's 3x plus 20. If we added that angle to x, they would equal 180 degrees. They're on the same line together. So I can simplify this. 3x and x is 2x. 20 is still 20, so 3x plus 20 is 180. Now, if something, we don't know what this is, plus 20 is 180, then I reason that 180 minus 20 gives us back to that something. Going back to the idea, for example, that, I don't know, 2 plus 3 is 5. Therefore, 5 minus 3 is 2. Well, here 2 something plus 20 is 180, so 180 minus 20 is 2x. And 180 minus 20 is 160. Okay, so 2 times x is 160. So what times 2 is 160? And that's 80. And I know because if I divide both sides by 2, I get x equals 80. And that's my answer. X is 80 degrees. And that makes sense. Let's plug it in. Here we have 80 degrees for x, and then we have 3 times 80, which is what? 240 plus, wait, something must be wrong, plus 20, that's 360 plus 80. Okay, what did I do wrong here? Let's go back. 3x plus 20 plus x has to equal 180. Okay. Oh, look what I did. Going back, right back to the start. Oh boy. That's okay. I'm glad I plugged in. In fact, I guess we should look at that as well. When you get an answer like this, plug it in, see if it makes sense. I know it doesn't because my angle measures way over 180. When I had 3x and x, I subtracted them to get 2x. But in fact, 3x and an x is 4x. So now, I'm going to just rewrite that through the problem so I have that in there. So 4x is still going to equal 180 minus 20, and 4x equals 160, but this time I divide by 4 on both sides, and 4 divided by itself cancels out. 160 divided by 4 is 40 degrees. And this makes more sense. X is 40. Here x is 120, 3 times 40, plus 20, which is 140, and 140 plus 40 is 180. So x equals 40 degrees. Okay, hope that helped, even though I made that mistake. All right.